Note 6, continuity 2, and integral rates of change. So here we go. The first two examples are nothing dealing with calculus. Nothing. It's just algebra. Now, why did I put those two examples in there? Well, there's a hint here because those questions are asked in continuity 2. I'm not sure why they ask those questions when it has nothing to really do with continuity. I mean, I guess there's discontinuities in locations, but not on that one. This one's just domain all row numbers. Okay, so let's talk about what this means. I want the left side expression to be positive. That's all it means. That's what this means when it says greater than 0. So I just want the left side expression to be positive. So how do you do this? Well, first, I'm going to find numbers where that expression is 0. And eventually, right now, they're not called anything, but eventually we're going to call that critical numbers when we take a derivative because something's happening there. But right now, we're not going to call it critical numbers. We're just going to find where this function is 0. So I'm going to put first, find where expression equals 0. So I find that this expression equals 0 if x equals 5, because 5 minus 5 is 0, and 0 times anything is 0, correct? And then 4 times what is 28? So x equals 7 is another value where x equals 0. Does everyone see how I got those values? All right, now to help, I'm going to do a number line. My domain is all row numbers, so I can just do my number line like so. And I'm going to put a 5 right here, and I'm going to put a 7 right there. I'm going to choose random numbers to the left of 5, to the right, between 5 and 7, and then bigger than 7. And all I care about, I don't care about the end result, the product, I care about the sign, whether it's positive or negative. Cool? So I'm going to choose a number to the left of 5. What's the easiest number for you guys? 3. Okay, I was going to say 0, but 3 is fine. Yeah, 3 is fine. Let's see. 3 minus 5 is negative 2. Negative 2 squared is a positive number. And maybe you're saying, Chavez, you didn't even have to look at that as being squared. It's positive all the time. Awesome. That's how you should be thinking. But right now we're going slow. The x minus 5 is always going to be positive. Do you guys see that? All right. What is 4 times 3? And 28 minus 12, is that a positive number or negative? So I'm going to put a plus symbol there. So everything to the left of 5 is always going to be positive. Give me any number between 5 and 7.
6.
Okay. You guys chose the one right in the middle. That's fine. It doesn't matter. 5.75, whatever. So the x minus 5 is always going to be positive. What is 4 times 6? Uh-oh. 6, 12, 24. 28 minus 24. 28 minus 24, is that positive or negative? That's still positive, so put a plus symbol. That means everything in between 5 and 7 is going to be positive. Now give me a number bigger than 7. 8, 10, I think 10 is a good number, but 8's fine. Again, the x minus 5 squared is going to be a positive number because I'm squaring it. 4 times 10 is 40, and 28 minus 40, is that positive or negative? Negative. Are we okay? All right, so now they want to know where this is true. Remember, we can't equal 0 because it doesn't have an equal sign on the bottom. So where is this expression positive? It's positive from negative infinity all the way to 5, union, and from 5 all the way to 7. You do not put a bracket because it does not have an equal sign. How do we feel? Oh, union's just a fancy way of saying the word and. So, negative infinity to 5. I'm sorry, say it again. It can't be 5 or 7.
Wait, why is that? Oh, because we didn't know the process.
Yeah, we did this. We want to know where this expression is bigger than 0, which is just a fancy way of saying where they're positive.
And when you say less than 5, that means it can also be negative numbers?
Yes.
Oh, yeah, because we positive.
How do we feel, guys? All right. So now look at this one. This one's a rational function. You guys ready? So remember, I'm going to find where this function, this rational function, is either 0 or undefined. Cool? All right. So I am 0 when x is equal to 5. Does everyone know how we got that? 2x minus 10 equals 0. 2x equals 10. X equals 5. All right. Now, where are you undefined? At x equals 2 and at x equals 8. Yes. Because you can't divide by 0. So if I were to graph this function, I would have vertical asymptotes at those two coordinates. At those two x values, because it's not a coordinate. Are we okay so far, guys? What's up, Marispe?
So is the numerator always going to be like the x is there when it's at 0?
Yes. My domain will not exist if I have a 0 on the bottom because I can't divide by 0. So what forces this expression to be 0 if x was 2? 2 minus 2 is 0. Or if x was 8, 8 minus 8 is 0. Since none of the factors canceled out, we would call those vertical asymptotes. Are we okay so far, guys? All right. I'm going to do a number line and relax. We know that it's not defined at 2. So here's what I'm going to do. I'm going to put 2. And remember, x equals 2 is a vertical asymptote. And I'm going to put 5. X equals 5 is a vertical asymptote. If I call this a function and I were to graph it, it will be a vertical asymptote. And find. Oh, yes. That was a lie. 5. And 8. X equals 8 is a vertical asymptote. Sorry about that. No harm done, I hope.
Wait, so that's what is 5 again?
5 is just where it crosses the x-axis. It's a 0. We're okay? All right. We just care about where this expression is negative because that's what this means. I want to know where this expression is less than 0. That's a fancy way of saying where is this expression on the left? Negative. Does that make sense? All right. Let's choose numbers. I'm going to choose a number. What's the number to the left of 2 that's the easiest for you guys? 0. Well, any number really, but 0 I think is the easiest. If I plug in a 0, you just care about positive or negative. If I plug in a 0, I get a negative 10 in the top. If I plug in a 0, I get negative times a negative, which is a positive. But what's negative divided by positive? So I'll put a minus sign there. Give me a number between 2 and 5. 3, 4, it doesn't matter which number. So let's see. We just care about positive and negative, guys. 2 times 3, I'm going to choose 3. 2 times 3 is 6. 6 minus 10, positive or negative? So hold that in your brain. In the bottom, 3 minus 2 is a positive number. 3 minus 8 is a negative number. Positive times a negative? Negative. What did I have in the top? Negative divided by negative is a? Put a plus. Give me a number between 5 and 8. 7. I heard 7 first. 6. It doesn't matter which one, guys. So 7. 2 times 7 is 14 minus 10. Is that a positive or negative? Positive. Hold that in your brain. 7 minus 2, that's positive. 7 minus 8, that is positive times a negative? Okay, what did I have before? Positive. So positive divided by negative is a? Negative. There it is. Put a minus sign. Give me a number larger than 8. 10. 2 times 10 is 20. 20 minus 10 is the positive number. That's what we care about. 10 minus 2, positive. 10 minus 8, positive. Everything is positive. What do I get? Positive. What are my answers? From negative infinity all the way to 2, and from 5 all the way to 8. No brackets anywhere. You're good.
Oh, it's avoiding the problem.
Yeah, we want, yes. Yes.
And how would there be a bracket?
If there would have had an equal sign here, there would be a bracket on 5. And only 5.
Why not 2?
The other ones are vertical asymptotes. So if, all right guys, real quick, because that is going to come out. If it had an equal sign, there would be a bracket on only 5 because the 5 is the one that creates the 0. Does that make sense to everyone? If it had an equal sign, there would be a bracket on 5 only. It would not be on 2 and on 8 because those are vertical asymptotes. Cool? What's up, Arispe? If it had an equal sign, you would not hit 2 because it goes down, 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 down forever. And then, well, from the other side, it goes up. What was it? Yeah, you don't cross vertical asymptotes. What's up, Rubio? You had a question? Oh, okay, sorry. What's up?
So for the first one, if it was an equal sign so like it was like positive and 0.
Oh, okay.
Would it be brackets around 5 and 7?
Yes. If number 1 had an equal sign, it would be brackets on 5 and 7. Are we okay so far, guys? All right. That was your lesson on, what do you want to call that? Algebra? All right. What is the secant? What is the tangent? What is the normal? So draw a random curve. What type of curve do you guys want? Increasing, concave up, increasing, concave down, decreasing, decreasing, concave up, or concave down? Okay. Decreasing, concave up. Let's put more of a curve. There we go. That's a nice curve. Yes. Concave up means it like it's a bowl, and it like opens upward and yeah. Well, I guess I can draw it real quick. That's concave up. That's concave down. All right. Oh, you guys are good. Sorry. All right, guys. Here we go. A secant goes through 2 points, and it can be a line that goes forever. This is what you call a secant. It doesn't have to keep going forever. You might remember this from geometry. It doesn't have to keep going forever. You could have stopped right, inside that circle there. Sometimes they call it a chord. Are we okay so far? Oh, we're gonna do this so much that it's gonna become common knowledge. Maybe not right now, but it will. A tangent. Oh man. I'm trying to draw my tangent perfect, guys. Nope. There we go. That's a tangent. All right, guys. And the normal is perpendicular to your tangent. Do you guys have experience with tangents, secants, and normal?
Tangent and secant, yes.
You guys have all had physics, so you should have done a whole bunch of tangents and normals when they tell you find your tangent force, find your normal force. No, I'm sure I've seen some blocks diagrams where I saw the normal force and the tangent. All right. So what is a tangent? Let me explain it to you guys. Imagine, what should we imagine? Imagine a basketball. Can you guys imagine a basketball? And tied to a string, like tethered to a string. Oh, there's a tether ball, right? A tether ball. Imagine a tether ball. Are we okay? So, and we're doing a bird's eye view. So this dot here is you. All right, guys, focus, because we're doing conceptual here. So bird's eye view, so that everyone knows what a bird's eye view is, right? Okay, from the top. Bird's eye view, here's your tether ball, and I'm spinning counterclockwise. So I'm spinning like this. And I'm supposed to be going in a circle, right? Because I'm just spinning, and I'm going counterclockwise. So a tangent is, if I were to let it go right there at this moment, let me go put it in red. If I let it go at this exact moment, where is it going to go? It's going to go on a tangent. Do you guys see that?
Yes.
That's what a tangent is. What is the normal? Well, the normal is perpendicular. That guy right there. That's your normal. If you were spinning. Do you see that? Yeah, the strain would be the normal. If the sun were to disappear just immediately, the Earth would float on a tangent. Because Earth rotates around the sun, right? So if the sun were to disappear just immediately, and of course there's other gravitational waves of the moon and all that, but if the sun were to disappear immediately, Earth would go on a tangent. It would go straight.
In that example, it was if the ball was let go, right?
Yeah, if the ball was let go, the ball would go straight at whatever that moment is. Does that make sense, guys? Okay. Then I think we are good, and I think we can continue.
Wait, what's secant?
Oh, secant is just, it goes to 2 points. Boom. Yeah, don't worry, we're going to do a whole bunch. All right, so here we go. And don't worry, we're going to start off very simple. Example 1. Does this look like a question you could have done when you were in Algebra 1? Yeah, find the average rate of change of f of x equals x cubed minus x over the interval 1 to 3. So what would you do if you were in Algebra 1 if they asked you this question? Bless you. You would just do... Perfect. You would go f of 3 minus f of 1 divided by 3 minus 1. You're just doing slope, the average rate of change. y2 minus y1 over x2 minus x1. Do you guys see what we're doing? So I'm going to go here to the side. F of 1 equals 1 cubed minus 1, which is just 0. F of 3, which is 3 cubed minus 3. 3 cubed is 27. 27 minus 3 is 24. Let me know. I make mistakes all the time. The equation is x cubed minus x. Are we still okay, guys? All right. So I'm going to write 24 minus 0 over 3 minus 1, which I guess we didn't have to do that again. 24 divided by 2, which is, so the average rate of change is 12, which is the slope of that secant line between 1 and 3. How does x cubed minus x look like? You guys know how it looks like? I know the cubic function and then the x makes it more linear as we... Don't worry, we'll do a visual right now. Here's the visual on the next one. Are we okay so far, guys? Yeah. All right. So here we go. Here's your, for you visual learners, it says, example 2, use points P and Q to compute the average rate of change and the slope of the secant line PQ. And you can see that it says flies per day because I stole it from some question that was talking about flies. So here's point P, here's point Q. Do you guys see how they call that the secant line? They want to know the slope of that. The slope is your average rate of change. So at point Q, it's 45,340. So that's what I'm going to do. I'm going to go 340 minus 150 divided by 45 minus 23. Now I know they tell me that it's approximately 9 flies per day. I'm going to go ahead and get the actual number in decimal. And let's do 3 digits after the decimal. So I'm going to take my little calculator. If make sure every opportunity you get to use your calculator, guys, use it so you can get really used to it. Don't worry, we're going to have a day where we just do nothing but calculator. And I'm going to go 340 minus 150. divided by, notice that I'm putting a parenthesis, 45 minus 23. $8.636363636363 probably goes on forever. Dot 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 means it keeps the pattern. Actually, the line on top means it keeps the pattern. Dot 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 means it keeps going forever. 636.
That's our answer.
Yeah.
Just the lines over all of those, or
You can, yeah, you can keep, you can, I think normally they do it all over all of them, but I would just 636 keeps going. Cause that's a pattern. 636 and then repeat. Yeah. 6-3, then let me, there we go. Yeah, you're right, miss. 6-3-6-3-6-3. There. And the next one will be 6-3-6-3-6-3. Are we okay, guys?
yes.
All right. Now, we're not ready for example 3. I did an accident. I had it in my notes, but I didn't change it. We're going to do example 4 first before we do example 3, but I want the idea of example 3 to be in your head. So let's look at what example 3 says. Find the slope of the parabola y equals x squared at the point 2, 4. Write an equation for the tangent to the parabola at this point. So what do they want? Let's do a quick visual. So here's my parabola exaggerated. And here is the point 2, 4. And they want this tangent. Do we have the skills necessary to do that? Well, maybe. We've just covered limits. We're going to see right now. You have I think you have the skills necessary. We just need to put it together. And that's where we're going to do example 4 first. And next year's notes, I'll put example 4 first and then example 3. So let's do example 4 first, but make sure that you keep this in the back of your head. So look at example 4. If it was on the inside of the parabola, it would be a secant, right? Because it goes through 2 points. A tangent only hits 1. All right. So here we go, guys. Ready? We're going to go slow. So everyone follow along with me. Example 4. The function f of x equals 2x squared minus 6x minus 70 is graphed to the right with some secant lines. Can you guys see those secant lines? I should have done a better job. All right. Sorry if we can't see them. Look, there it is, guys. But I didn't do a really good job. Well, it looks like tangents, but they're going through more than 2 points. The only tangent line maybe is this one in red. But the green one is going through more than... See, the green one's going like... All right. Yeah, they're so close to the tangent that they look tangent. Which I guess I kind of gave a hint there. Darn it. All right. Determine the slope of the secant lines for f for each of the intervals indicated in the table. Find the slope of secant lines of f on the interval 3, x2. For each value of x2 as shown in the table, write your answers as decimals. Okay, these are your x2s. In case you're wondering, Chavez, I have no idea what this is telling me to do. It's telling me to find the slope of several secant lines as I get closer and closer to what x value? 3. So it's telling me to do, so here's what it's telling me to do, guys. I'm going to find my slope. This is an interval, by the way. This is an interval. I'm going to find my slope between 3 and 4. Those are x values. So my slope, I'm going to put a semicolon. I'm going to go m equals, so what do we call it? F? Yeah, because it says f over there. F of 4 minus f of 3 over 4 minus 3. Are we okay? All right. And then I'm going to go ahead and do the next one down here. I'm going to go 3 comma to 3.1. Those are x values. Have I confused anyone? All right. Semicolon. My slope for that one, we haven't figured out any of these values yet. F of 3.1 minus f of 3 over 3.1 minus 3. Does everyone know what we're doing? Okay, I'm just using my point formula.
3 minus
3.1 minus 3.
Oh.
x2 minus x1.
Oh.
And then I'm going to go 3 comma to 3.01, semicolon, slope, f of 3.01 minus f of 3 over 3.01 minus 3. That's going to give me some number. And then finally, 3 comma to 3.001, semicolon, slope is equal to f of 3.001 minus f of 3 over 3.001 minus 3. Everyone know what we did right there? Okay, we're going to get those numbers. If you have a calculator, I recommend that you do this with me. If not, I guess you can just observe, but I recommend you try to do this with me, guys. So get your calculators out. Whatever calculator that you're going to use on the day of the exam, that's what you should be using, guys. So get your calculators out. On y1, I'm going to type in this equation. 2x squared minus 6x minus 70. So type that in. 2x squared. The x is right next to the alpha key, guys. And I already forgot it. Minus what? So do that. Everyone type that in? Okay, go to the home screen. So second quit. So your home screen looks like this. And don't worry, we're gonna go slow. So I'm gonna go. This is what I'm gonna do, guys. I'm gonna push alpha, the trace button, and I'm gonna call number 1. Does everyone see how I got y1 there? Open a parenthesis. And what I want to calculate first is the very first one. So y1 of 4 minus alpha trace y1 of 3. And I forgot to use parentheses. So let me put all this in the numerator. Second, insert, parenthesis, second. Okay, let's start again. Ready? Yeah, clear it. Let's use the fraction feature. So I'm going to push alpha y equals, enter. There we go. Now we can just do top over bottom. I push the alpha, and then I push the y equals. Oh, how do you get the y? Okay, where are you guys at? To the home? Second quit. Second quit. Alpha y equals, okay, there we go. Now we're back. We're okay right now, guys? All right. Alpha trace, and then push enter. And then open parenthesis, put number 4, and then close it. Minus alpha trace, push enter, open parenthesis, put 3, close it. So what that's telling the calculator is to do y1 and insert the x value 4, minus y1 again, and insert the x value 3. That's what it's telling the calculator. This is coding. So if you like this, then you'll like programming. And in the bottom, I'm just going to put what? 4 minus 3. And I'm going to push enter. And I get a number. What number do I get? Type that in your table. We're going to do the same thing again. Yeah, that's what I'm about to do again. Ready? Alpha. Well, first I'm going to put the fraction. Alpha trace, enter. So here we go. Alpha trace, the trace button. Enter. There's my y1. And now I want what? 3 point alpha y equals. And then enter. 3.1. Close. Minus alpha y equals. Oh, no. Alpha trace. Alpha trace y1 at 3.
Wait, and then how did you make the fraction?
Alpha y equals. And on the bottom, I'm going to go 3.1 minus 3. Let's see if it gives me a fraction or a decimal. Yeah. What do you guys get? Put that in your table, guys. The table of that, this guy right here. This table right here. Secant slopes. 8, 6.2. Oh, because all I'm doing is y2 minus y1 over x2 minus x1. And on all of them, x1 is 3. See? On all of them, x1 is 3. All right, keep going. So here we go. I'm going to do it again. Ready? I get the fraction feature, alpha y equals, enter. And I'm going to go alpha trace, and I'm going to type in enter for y1. And I'm going to open parentheses, 3.01? 3.01 minus alpha trace. The more you do this, guys, the better you're going to get at using your calculator. Alpha trace 3, close it, all over 3.01 minus 3. 6.02. Type that in. And then finally the last one. I think you can scroll up, guys, and push enter. And there it is. And then you can just go 3.001. Second, insert 0. And then let me scroll up. Second, insert 0. All right, let's see.
Okay, so this is what I found. So I put the graph in menu, trace the, and you can do like put in enter value, but then after that I don't know what to do.
Push OK.
And then it says that like you put it in that little box.
You have it under f of 1? Okay, so I think what we can do, as long as, oh, this is Scratchpad. I don't know if we'll be able to. I think we have to do you have to do it under document, so you can call it, you know what I mean? So do under new document, and then add calculator, and then go ahead and add graph to this document.
Okay.
And then once you add that, then you can call it from the, as long as you're in the new document, in that same document, you can call the f of 1. You know what I mean? Does that make sense?
No.
I'll go over there to your table right now. All right, give me this slopes, guys, at 3.01. What did I get? And this one is, all right. So 6.02, 6.002. All right, so here we go. Do they ask me any questions here? Nope. All right. So here's what's happening. You guys ready? So I need everyone's attention really quick. Well, AB attention. So I want to figure out my slope at x equals 3. Do you think if I keep getting secant lines closer and closer to that tangent, see how what you're doing there, that eventually that I can get my tangent slope? Yeah, so there's my blue line. And then notice they just choose numbers closer and closer. So, and what did I want it? I wanted it at 3. So I guess I should have written it like this. So sorry, guys. Let me see if I can do a better visual. So there's one secant, and then here's another secant in green. And then eventually, see, as I get closer and closer to the value of 3, you're getting closer and closer to your tangent slope at 3. Does that make sense, guys? Now, why am I saying tangent slope at 3? Remember, at the tangent point, at x equals 3, my tangent, you only have one coordinate. You cannot find a slope with one coordinate. You need 2 coordinates from your algebra days. Does that make sense? So notice with limits, oh darn it, I kind of pretend I didn't say that word. Notice, yeah, I didn't say anything. So I have a 4 here, then I have 3.1, 3.001, 3.001. What's happening to my secant? What's happening to that x2? It's getting closer and closer to what? Yeah, 3. And my slope definitely has a value that is getting closer and closer to. It's getting closer and closer to 6. Now, we're going to say that your change in x. So here's what we're going to do, guys. We're going to make a connection right now. Your change in x, we're going to call that h. Is that okay with you guys?
Yes.
So here's what we're doing. I'm going f of some x value plus h minus f of minus f of x over h. Relax. All I did right now, and I guess, guys, all I did right now is just this. X comma f of x. That's just an ordered pair. That's just an ordered pair. I didn't do anything crazy, guys. And then I got another ordered pair, and I called it x plus a little more. That's your delta x, right? Delta x just means how much you change. X plus a little more, comma, f of x plus that little more. That should be an h. It just came out wacky. Does that make sense? Now check it out. This is y2 minus y1. And then, Chavez, how'd you get that h in there? Well, we did x plus h minus x, and then the x's cancel out, and it's just h. Now, if you want the... Okay, I'll slow down because I want to make sure that we really got that down. Okay, so I'm going to say it again. I'm going to write it right here in the blank space here. So my secant slope, I'm going to write secant slope can be calculated by slope f of x plus h minus f of x over h, comma, where h is just change in x. It's just how much you've moved.
Yeah. Wow, I can't believe for an entire year we've been doing that and we didn't know what it was.
We're good, guys. We're good. Now, remember, guys, right now, this is how you calculate secant slope if you're giving an ordered pair, x, f of x, and x plus a little more, f of x plus that evaluated at that little more, delta x. Okay, are we okay so far? This is how you find secant slope. Now, let me ask the big question. Let's see if we know. How do we calculate tangent slope?
Limit of that.
Limit of what?
Oh, secant.
Okay, as what approaches what?
X approaches whatever the
As x approaches
There you go.
No, it's whatever the point that you were using.
So, yeah, so let's all right, guys, we're close. You guys are so close to getting it. I want my tangent slope. So how do I find, I want you guys to observe what's happening to the denominator as I was finding my tangent slope. Okay, so how do I find my tangent slope? Using this formula.
Oh, as h approaches.
There it is. Do you guys see that? So to find tangent slope, we want h to approach 0. Because we don't have two coordinates. If h approaches 0, that means we're literally on that point. Does that make sense, guys? So here's how my tangent slope is going to look. My tangent slope, I'm going to put t, stands for tangent. It doesn't always stand for tangent, but for now. Limit as h approaches 0 of f of x plus h minus f of x all over h. If you understand that, you're winning. Can you trick me by being a robot? Yes, you can trick me. But I really need you to understand that concept. This is how you find your tangent slope. This is how you find your secant slope. What's the difference? One of them has a limit as h approaches 0 because you are at a coordinate and you need 2 points to find a slope, but we don't have 2 points, we just have 1. So that's why h is approaching 0, and the other one does not have a limit because you have 2 coordinates to find the slope.
Does that mean that? Oh, okay. So tangent slopes, like when you calculate it, it will always be undefined. Or
No,
like-
if it's a curve, you will be able to calculate a tangent slope.
Oh, okay.
Don't worry, we're going to see right now. All right, so let's go back to example 3, guys. And don't worry, we're going to go real slow. We're going to give you guys an idea. If you are scared about the limit process, you can zoom in. Zoom in with your calculator and get 2 points super close to each other. So if I want the slope at 2, you can get me the point of 2 and 2.0001 or something. Does that make sense? Just like we did down here with this. Look, they got 2 points really close to each other. And if you get 2 points really close to each other, it's going to look like a tangent. Does that make sense? But we don't want to do that method. We want to do the method we just learned right now. So what method did we just learn right now? We learned this. We learned that my tangent slope is equal to the limit, and we're going to rewrite this over and over until it's embedded in your brain, of f of, this time I want it at 2, so I'm going to write 2 plus a little bit past it, minus f of 2, all over h. Do we understand that formula at the moment? Because I want my tangent slope at x equals 2.
So the 4 doesn't really matter.
Well, that's a y value. We're going to need it for f of 2. f of 2 equals 4.
Okay.
So here we go. F of 2 equals 4. We got that from the equation, 2 squared. And I need f of 2 plus h. So what was f of x? It was f of x squared. So 2 plus h squared. Does everyone know where I got this 2 plus h squared from? Be honest. No? Okay. You see this function here? That's the equation that we want. So f of x is x squared. We want the tangent line of x squared at x equals 2. Did I answer your question, guys? Okay, here we go. I'm just expanding it. 2 times 2 is 4. 2 times h is 2h, and you're going to have how many of those? So we're going to write 4h, and h times h is h squared. Chavez, what is h? H is just some number past the 2. 2 plus 3, 2 plus... Of course, you want h to approach 0, but h is just delta x. Are we so far okay, guys? All right, now we're just going to do our little formula. Mt equals limit as h approaches 0 of 4 plus 4h plus h squared minus 4 all over h. We're going to zero out some stuff. Force zero out each other. I can factor out an h, so I guess let's go ahead and rewrite it again. Limit as h approaches 0, h factored out. 4 plus h, actually that's it, all over h. And then what's going to cancel? The h's. Now can h approach 0? What's my limit? So that is my tangent slope. Don't worry, we're almost done. Do I have a coordinate? Yes. So here's my equation. Y minus 4 equals 4x minus 2. On the AP exam, you can leave it like that. I did point slope formula. Y minus y1 equals slope x minus x1.
Oh, okay. Wow, that just brought back memories.
Point slope formula. On the AP exam, you can leave it like that. For now, we're going to write it better. If you are prone to making mistakes, leave it alone. And the BC class can attest to that. If you are prone to making mistakes, leave it alone. Here we go. Y minus 4 equals 4x minus 8. Let's solve it in terms of y equals mx plus b.
Where did you get this 4 to the variance?
This 4 from the coordinate. This 2 is from the coordinate. That 4 is from the slope. Yes. Yes, ma'am. Yes. Let's watch a visual and don't worry, catch up. Check this out, guys. You guys are gonna like this. I'm gonna take my calculator. You don't have to do this with me. I just want you guys to see it. I'm gonna type x squared. And what would I say my tangent line was? 4x minus 4. Look at this. Hopefully it looks like a tangent. I might have to square my window. Okay, it looks like a tangent. That looks like a tangent. Let me zoom in a little better, though. Oh. Let me zoom in right there. Yeah, it looks like trace. Okay, let me zoom out. Sorry, guys. Zoom out first, and then zoom in. Okay, now zoom in. Zoom in. It looks like a tangent. It's not. My graph is not super awesome. Kind of not liking that. Can I square it? 5. It looks like a tangent. I guess let me just make it normal. Maybe it was already good to begin with. That's probably the best view. Yeah, it looks pretty good to me. Do you guys see that? All right. Now, by the way, guys, you just found an instantaneous rate of change at x equals 2. Write that down. Tangent line. Well, I guess write this down quote for quote. We found an instantaneous rate of change at x equals 2. And don't worry, I'm going to say it again. Quote, unquote. Quote, we found an instantaneous rate of change at x equals 2. What does that mean? Travis, what does that mean? That means that we literally found, if we were scrolling around this curve, if we were just walking, we found the rate of change at 2, like what we would be at that moment. And don't worry, I'm gonna show you guys visuals and all that good stuff. I just got to create the visuals first. So I have some software that I can use, and it's gonna be really cool. Cool or not cool? So this is why calculus is so powerful, especially in physics. Before, they can only ask you questions that are, what's the average velocity? What's the velocity at this moment? Now they can ask you for instantaneous velocity at any given time. But we're not there yet, but we're getting there. Are we okay so far, guys? What's up? Yeah, go for it. All right. I think, let's see, can we do another one? Yes. Let's do this one here. Let's see if we can now do this without much complications. You guys ready? Say it again. Oh yeah, we're not going to be able to finish this too much. So we'll stop at, should we stop at example 5? All right, it says write an equation for the tangent to the curve f of x equals 4 minus x squared at x equals 1. To draw a tangent, to put a tangent line, I need 2 things. I need a slope and I need a point. Cool or not cool? So what are the 2 things I need? All right, tell me again. What are the 2 things I need, guys? One more time. Okay, do I have a point? Yeah, kind of. I can get it. I have x equals 1. I can get it. Let's see what that point is. F of 1 equals 4 minus 1 squared. 4 minus 1 equals 3. So my point is 1, 3. Now I need a what? Slope. How am I going to find a tangent slope? You just did it a little while ago. Limit as h approaches 0. You can also say delta x, but h is better. Limit as h approaches 0 of f of 1 plus h minus f of 1, all divided by h. Are we cool? All right, we already know what f of 1 is, but we don't know what f of 1 plus h is. So go to the side somewhere and go f of 1 plus h equals 4 minus, parenthesis, 1 plus h, close it, squared. Have I confused anyone? All I did was plug in 1 plus h in for x. It's because it says x squared here. So anytime you have, let me show you this. F of happy face equals 4 minus happy face squared. So whatever I type in inside my argument, so if I plug in 1 plus h as an argument, then I got to type in 1 plus h wherever I see an x. So So here we go. 4. Now it's just arithmetic, guys. Parenthesis. 1 times 1 is 1. 1 times h is 1h, but you're going to have how many of them? So 2h. And h times h is? Distribute the negative. 4 minus 1 minus 2h minus h squared. 4 minus 1 is 3. So there it is. There's my f of 1 plus h. Are we okay? All right. Now, I'm going to come back, and I'm going to write limit as h approaches 0. And this is my f of 1 plus h. So I'm going to write 3 minus 2h minus h squared minus, what was f of 1? 3 all over h. Are we still okay? All right, we're going to zero out some stuff. The 3's zero out. And I can factor out one of the h's, correct? So cancel, cancel, cancel. And what is h approaching? 0. So this is just negative 2. Do I have my slope? Do I have my point? The slope is negative 2. So here's my equation, guys. I'm using point slope formula. y minus 3 equals negative 2. X minus 1. If you are prone to making mistakes on the day of the AP exam, you can leave it alone. But right now, we're not looking at strategies. Just solve for y to get my equation. Y minus 3 equals negative 2x plus 2. Move the 3 to the other side. Y equals negative 2x plus 5. Did I do that right? That is a tangent line. And I know I said this was the last one, but one more, guys. It's an easy one. It won't last this long. Ask. Say it again? No, you could do y equals mx plus b, but it just thinks it takes too long to solve for b that way. I think point slope just solves it, gives it to you. Are we okay, guys? Yeah. To the right, to the right. Okay.
Yeah, I was like, what is this?
Like, I never really, because I was always like, I guess it's a cool, like, thing, but I was like, why?
All right, guys, check this out. Don't worry. We're about to be done. This will be the last one. It says write an equation for the normal to the curve. So we know that a tangent and a normal, they intersect to become, and they're perpendicular to each other. Yes or no? Yes, that's what we did earlier. So if they're perpendicular, tell me something about my slopes. Opposite, reciprocal. So my new slope, the n stands for new. I guess you could also say normal. My new slope has to be 1/2. So here we go. I'm doing the same thing again, guys. Y minus 3, I'm just using my same point because the normal crosses that same point, equals 1/2, parenthesis, x minus 1. Is everyone okay so far? Check it out. Y minus 3 equals 1/2 x minus 1/2. Add 3, Travis, I can't do that. Yeah, you can. That's the same. 3 is the same thing as 6 over 2. 6 divided by 2 is 3. So negative half plus 6 is 5. So y equals 1/2 x plus 5 over 2. Now, guys, I want to see a visual, so I'm going to show you guys something. This is normal. This is your normal line. Anytime you get an opportunity to use your calculator to see a visual, I think you should use it. So check it out. I'm going to type in my y1, 4 minus x squared, because that's the equation, right? 4 minus x squared. And then what did I say was my tangent? Plus 5. And then what did I say was my normal? 1/2 x plus what? 5 over 2. Now check it out. Let's see if it really does look like that. Look at that. Well, okay, hold on. Now this is going to be a perfect way. At the moment, the way it looks, you're like, Chavez, you told me they were perpendicular. That doesn't look perpendicular. Relax, guys. This is not a square window. So to tell your calculator to become square, there's a button. Click on zoom. We should have done this as an example. And you see the one that says square, number 5? Watch. If you push number 5, it's going to square the window. And now look at that. You can fit a piece of paper at that edge because it's a perfect 90 degrees. There's squigglies because it's not perfect, but look, there it is. It's 90 degrees, guys. Perpendicular. That's my tangent. That's my normal. Isn't that cool? Oh, you guys don't like that? What's the question, Miss Rubio? You had it? I heard you. Don't get mad. Okay, I'll check right now with you, Miss. No, I did not use parentheses. I just, check that you put a negative and not a minus with the 2x. The negative is next to the enter button. I like this. Did you guys get something like this? My graph kind of gave me a little squigglies. Did yours get squigglies? I don't know if it's my emulator or if it's my calculator. You don't have squigglies? Oh, you do? Okay, maybe it's the emulator then. It's the programming issues. But do you see how it looks perpendicular? Push zoom. And number 5, square. You guys have a powerful tool in your hands with that calculator, guys, so use it every day. You got it? Good. You're going to get college credit, miss. You're going to beat up every exam. Are we doing okay, guys? All right, let's go ahead and I'm going to call it a day, guys, because I think we've had enough. But did we learn today?
Yes.
All right, we'll continue this tomorrow. All right, guys. We left off, today is the 25th. We left off in example 6. We finished example 5. And we talked about the tangent slope. And we said that is, did we ever use the word instantaneous? No? Instantaneous rate of change. Instantaneous. We found that slope, instantaneous, that is an instantaneous slope. And rate of change means slope, right? So a tangent slope is an instantaneous slope. Cool or not cool? All right, here we go. I just changed the little spiky on this little pen or digitizer or whatever they call it. So let's see how it writes. All right, so this says find limit as h approaches 0 of f of t plus h minus f of t all over h for the function f of t equals 2t squared minus 1 at t equals 2. And then it says interpret the answer if f of t represents position function in feet of an object at t seconds. All right, so first let's just do this in the beginning. It just wants us to do this right here. I guess let's use a circle because I never use it. So let's just do that using this function at that time value. Cool? Sorry guys, I never used that little elliptical circle, so I thought it was kind of cool that I used it there. I don't know what color that is, yellowish or something. Alright, so here we go. Here's what I want, guys. I want to figure out f of 2. So 2 times 2 squared minus 1. So 2 squared is 4. 4 times 2 is 8. And 8 minus 1 is 7. So that's what f of 2 is. And now I'll also want f of 2 plus h. So 2 parentheses 2 plus h close it squared minus 1, which equals 2 parentheses 2 times 2. And let me zoom in. 2 times 2 is 4. 2 times h is 2h, and you're going to have 2 of those. So plus 4h plus h times h is h squared. Close it. Minus 1. I'm going to distribute that 2 there like so. Since I'm still working on it, this equal sign indicates the f of 2 plus h. So here we go. 2 times 4 is 8 plus 8h plus 2h squared minus 1. And then finally, combine like terms, the 8 and the 1 is 7. So 7 plus 8h plus 2h squared. And I know in your algebra days, algebra 1, algebra 2, it was conventional to write the polynomial with the highest degree in the front. I'm going to leave it like that. Are we okay? All right. So now I'm going to go ahead and do this difference of quotients. This quotient. So here we go. So I'm going to write the word limit as h approaches 0. I'm doing this now right here, guys. I'm doing that. So I guess maybe I should start by saying that statement first. So here we go. F of, I was going to write that statement. Limit as h approaches 0 of f of 2 plus h minus f of 2 all over h equals. And then since I'm evaluating the limit, I keep the word limit in there. Limit as h approaches 0. And then I write f of 2 plus h, which is this one right here. 7 plus 8h plus 2h squared minus, and then f of 2 was just 7 all over h. And I got some room, so I'm going to continue. I'm going to write the word limit because I haven't evaluated it yet. As h approaches 0. What's going to 0 out? The 7's 0 out. And then I want to show all the work. So for now, I'm going to factor out an h. So I have 8 plus 2h, close it, all over h. Now what's going to cancel? The h's cancel out. And now that I canceled the h's, can I evaluate this limit? Yes, this whole limit is just equal to 8. Are we okay?
Why just 8?
Oh, because h is approaching 0, so this whole, the 2h is just approaching 0. All right, so now they want us to interpret our answer. They're telling us that f of t represents a function. So this is easy to analyze, guys. That's just a parabola with the y-intercept at -1. So let's see, and let's just go ahead and assume that t is greater than or equal to 0. So it looks something like that. And this is position in feet. So think about what we just did. And time is in what? Seconds. What did we just do? What did we find? I guess in terms of the graph, what did I find? Okay, the tangent slope. The tangent slope at what time? At time 2. So I'm going to say time 2 is over here. It's not drawn a scale. So I just found my slope. So that blue line is a tangent line. I tried to draw a tangent line. Cool. I know that that blue line has a slope of 2. So what does the slope indicate in my position time graph? The blue line has a slope of, slope of 8. Slope of 8. T greater than or equal to 0, my domain. Sorry if I'm mixing words there. All right, let me see if I can say it correctly. I have a tangent line, and that has found the tangent line at t equals 2, and that tangent line has a slope of 8. Okay, what does the slope mean? What does the slope mean? Does it have a meaning? Look at the units, guys. Look at what my y-axis is in. Feet. And what is the x-axis in? So isn't my slope the change in y over the change in x? So my instantaneous slope at 2, I got 8. So this is 8 what? 8 feet per second. So what is my tangent slope giving me? The what? The velocity, the instantaneous speed. You can say speed for now. It's saying the velocity. It's saying the instantaneous speed. Does that make sense? So what does it give me? It gives me the instantaneous velocity at t equals 2. So I'm going to write this down. So here we go, because we have to answer the question, right? It says at t equals 2, interpret the answer if f of t represents position function in the object. Okay, so I'm going to write limit as h approaches 0 of f of 2 plus h minus f of 2 over h equals 8 is the velocity in feet per second. I'm going to go ahead and write out the whole shebang. Feet per second at t equals what? 2 seconds. It's an instantaneous velocity if you want to put that word right on top of it. Instantaneous. It's an instantaneous velocity.
Which just means that it's only at that instant.
At that moment, it is going 8 feet per second. What does instantaneous velocity mean, Chavez? How many of you drive? Okay. When you're driving on the highway and you look down at your speedometer, at that exact moment that you're looking at your speedometer and it says, I don't know, 73 or whatever, that is your instantaneous. Well, I mean, we're in Texas, right? West Texas, I-10. Everyone speeds in this state, guys, really. But when you look down at your speedometer, that is your instantaneous speed. Now, when you push a button, if your vehicle has it and it tells you your average speed, like, oh, your average speed is 47 miles per hour, that's your average speed. It's taking into account all the stop and goes and all that good stuff. Cool? Cool. All right, there we go. I think we're making gains. Are we cool? All right, let's keep going. Look at example 7. Now we got more physics type problems. A rock breaks loose from the top of a tall cliff. Okay. The position function of the rock is f of t equals 16t squared, where t is in seconds. And then I tell you this formula does come from somewhere. It didn't magically appear. Maybe we'll talk about it. What is the average speed during the first 2 seconds of fall? All right, do you guys want to talk about where this f of t equals 16t squared came from really quick? All right. Do you guys remember who everyone's taking physics, right? And then you guys are in physics. Okay, do you remember your kinematic equations for displacement equals velocity initial times time plus 1/2 at squared?
No,
Change in x equals velocity initial times time. Okay, times, I'll put times time plus 1/2 at squared. Oh, I mean, I wouldn't call it like a long equation, but okay. Yeah, no, if you're a physicist, which you'll know pretty soon, you're going to be working with, okay, anyways, so here it is. Here it is, an acceleration due to gravity around the world. I mean, of course, it varies just a little bit depending on your height because, you know, you're closer to the center or whatever. But everywhere in the world, it is approximately what? If you're in meters per second? Yes, if you're in the... What about if you're in feet per second? Does that one? The 3 sounded pretty good. 32 guys. Now, I personally, real quick, and it's I'm not throwing shade at anyone, I promise. I personally prefer 9.8 meters per second instead of saying 9.8 meters per second squared, because that's what it means, right? Like, what does acceleration mean? It means this is how fast you're changing your velocity every second. So what does it mean? Every second that passes, your velocity is increasing by 9.8 meters per second. So I personally like 9.8 meters per second, or 32 feet per second. So every second that passes, you're increasing your velocity by 32 feet. Does that make sense? Okay, so where did this 16t squared come from? Well, if velocity initial is 0, and we're using 32 feet per second because we're in America, that was a joke, but it wasn't funny at all. Half of 32 is, and that's where that 16t squared came from. Cool or not cool? Okay, so these functions, people don't just make them up, guys. These equations come from somewhere. They're used to model something. Cool?
Okay, you don't make these up?
No, this one. I mean, when it comes to free fall equations, you gotta use real equations that really happen, that really model the world. Okay, here we go. You guys ready? So.
Sean, you didn't want to be a physicist or anything? Like major in physics?
Miss, I have a degree in engineering.
I thought you majored in mathematics.
No, I have electrical engineering.
Oh,
Guys, all right, guys, let's focus. All right, here we go. So it says, what is the average speed during the first 2 seconds of fall? So I know that this is going to tell me my position, because it tells me the position function. Cool? So if I want to know the average speed, that's just regular physics. I can just do my position at 2, that's final position, minus my position at 0, divided by the change in time, 2 minus 0. Does that make sense to everyone?
So it's like y1 minus y2.
Yeah, it's exactly like that. It's just, it's a rate of change. Position final, position initial. Right, okay. Does this look similar to you guys, like physics a whole? Okay. So here we go. I'm going to find out what f of 0 is, which is just 0, right? 16 times 0 squared is just 0. And I'm going to find out what f of 2 is. 16 times 2 squared is 16 times 4, which is, what's that? 16, 32, 64. I want to say 64. So I'm going to write 64 minus 0, just for clarity in the notes, divided by 2 minus 0. So 64 divided by 2 is, and I need units. Yeah, what is the units? Feet per second. This is your average. This is not instantaneous. This is your average velocity of this rock that is falling down within the first 2 seconds. So between t equals 0 and t equals 2, the average velocity is 32 feet per second. These are the type of problems you did in physics because this is all you know how to do at that time.
So that's what he meant when I said, are we ever going to do anything other than average? And he said, yeah, you can do instantaneous, but you need calculus.
Yeah.
Okay, got it.
So now here we go. Oh yeah, ask. Yeah, instantaneous means at that moment, at 2 seconds. So when you're driving and you look at the speedometer, that's instantaneous. Yes.
So the difference between like questions A and B is that here they were asking us to find like average
Between t equals 0 and t equals 2.
Right, and so we just used 2 and 0
Mhm.
as our values for y or y2 minus y3.
Mhm.
But then for the second, like the part we're about to do, that's the one where we have to figure out like the tangent line because it's asking us about this particular mode that it actually said.
Perfect, yes. All right, letter B. It says, what is the speed of the falling rock at the instant? Underline that word instant. It's super important. At that moment. So now I am looking for specifically instantaneous velocity. Does that make sense, guys? So I am doing exactly what we just did in example 6. Do you guys see that? So how am I going to do it? I'm going to trick it. We still only know how to find, I still need position final, position initial, but I'm going to trick it by doing this. I'm going to go f of 2 and a little bit past 2. And I'm going to go 16, parenthesis, 2 plus a little bit past it. Remember that h, we'll talk about it right now, which is 16, parenthesis, 2 times 2 is 4. 2 times h is 2h. You're going to have 4 of those, or when you add them, it's going to be 4h. And then h times h is h squared. And then distribute. So 16 times 4 is 64, plus 64h, plus 16h squared. And I still need f of 2. And we said that was 16 times 2 squared, which was just 64, correct? Okay, and I'm going to slow down because I'm going to explain everything that I'm doing. I am treating f of 2 like position initial, and f of 2 plus h like position final. And I want h to approach 0. H is just the change in time. And we're getting closer and closer to the 2 second mark.
You have one point that is actually at t equals 2, and then you need some other point, so you need like t equals 2.0.
Yeah. If you wanted to, don't try to cheat the system, but if you wanted to cheat the system, like what Taylor just said, you can say, I'm just going to get so close to 2, and you can go, I'm going to choose 2, which is 64, and then go 2.000001, and that's pretty close to 2. It's not exactly at 2, but it's pretty close. And if you find that slope, it's probably going to be pretty close to the actual slope at 2, the instantaneous velocity at 2. Does that make sense? Okay, but I'm not going to do that route. I'm going to go ahead and do the real route. Cool? So what do I put before I evaluate? I'm doing this exactly, but I'm putting a word in front of it. Limit. Now that's where this comes in. So I write the word limit, and I write h. I want h to approach what? 0, because I want to find it exactly at 2. My final position, which is like the f of 2 plus h, minus the initial, f of 2. And I'm still dividing by 2 plus h minus 2, which is just h. Do you see how we got the h down there? Yeah, 2 plus h minus 2 just gives you... All right, so here we go. I'm just plugging in now. I'm plugging in this expression here. So limit, I haven't evaluated it yet, guys, so keep writing that word limit. 64 plus 64h minus 16h squared minus 64 all over h. In the numerator, let's first zero stuff out. What zeroes out? The 64 zero out. Now that I've zeroed out that, I don't want to do bad habits, guys, so I'm going to do one more line. I know some of you can just see it and be like, oh, factor out the h. But I want to factor out the h so everyone can see this here. So you can make this a habit. Oh, that's it. 64h plus 16h squared. Okay, so here we go. I factored out the h. What can I cancel out? The h's cancel out. Now can I do direct substitution? Yes, the 16h is going to be approaching 0 because it's 16 times 0. So I just get what? And I need units. What do I have in the numerator? What do I have in the denominator? Feet per second. You can write the word per or you can write the slash sign. So what did we just calculate? The instantaneous speed or velocity. For now, I mean, velocity is a vector, but we know we're falling down. The instantaneous velocity is 64 feet per second at t equals 2 seconds. So when you're writing your statements, don't worry, I'm going to answer. When you're writing your statements, make sure that we're specific. So we're going to write this rock is falling at 64 feet per second at t equals 2 seconds. I guess you could have said also the rock at t equals 2 seconds is falling at 64 feet per second. I think I like the second route better than this. But this is still correct. What's up, Taylor?
Why do you... So, it is very cool math, but why do you have to do this whole process? You get the same thing if you just put 2 into... Like, if you do f of 2, you get 64.
Yeah, but f of 2 is position at 2. You know what I mean? When I'm falling down initially at 0 seconds, I haven't fallen anything, and 2 seconds later, I'm 64 feet down. F of 2.
Oh, that's just... Oh,
F of 2 means that I've fallen 64 feet.
So it's just a coincidence.
Yeah, because of the numbers that we're using and the 2 and the 16. So at 2 seconds, anything that's going to fall, if it's falling from a position of 0, will have traveled 64 feet. And the velocity, if it doesn't have an initial velocity, will be 64 feet per second at t equals 2. Anything. Unless there's a lot of air resistance and you consider the shape of some curve. But we're not talking about frictional forces at the moment. Any other questions, guys? Yes, what's up? Find the instantaneous velocity, or find the speed at t equals a specific value. Find the speed at t equals 3. So then that means, I got to find the instantaneous velocity or instantaneous speed at that moment. Slope. Anything that deals with instantaneous rate of change. Slope. All right, check it out, guys. This equation came from somewhere. It didn't make it up. This is in Mars. Take a guess. That 1.86 is the gravitational pull of Mars. Isn't that cool? If you Google the gravity of Mars, you're going to get... You know what? Let's do it real quick. Let's just... let's Google it real quick.
Would you go to Mars
I don't know. No one's out there.
6 years in, you're supposed to be an astronaut.
Oh, I think that would be a cool job. 3 point what? Oh, okay. I bet you we're gonna get that if we. Do they want it at 1 second? 3 point. Okay. And this is also meters. So Alcocer found it for us, and watch. We are so lucky because they do want it at 1 second. So let's just talk concepts. So what is the gravity in Mars again, Alcocer?
3.721 meters per second.
Meters per second squared. Okay. So before we even start with the calculus, meters per second squared. So that gravity, if my initial velocity is 0, at the end of 1 second, my whatever particle I drop in Mars, at the end of 1 second, you should be traveling at a speed of what? 3.721 meters per second. At the end of 2, you double that 3.7 and whatever 3.7 times 2 is. Does that make sense to you guys? Yeah. All right, so look at the question. The equation of free fall at the surface of Mars is this equation, meters with t in seconds. Oh, perfect. This is in meters per second. Assume a rock is dropped from the top of a 200-meter cliff. Find the speed of the rock at t equals 1 second. Okay, let's just talk about it. Without any calculus, knowing this from Google, if this was dropped, assume the rock is dropped. If it was dropped, what's my initial velocity? 0. So at the end of 1 second, what must my speed better be? Yeah, 3.721 meters per second, just without the square. Does that make sense? So hopefully we're not fake, and after we do that whole calculus, hopefully we get that same number. Cool? We'll find out right now. We're about to find out. So here we go. This is position. I should have typed S of t, but that's fine. 1.86 t squared. I want to find my position at 1 second, and I want to find my position at 1 plus a little bit past it, so 1 plus h. So here it is. Yes?
Why is it S of T and not T?
Oh, they use different letters for different things, but usually S stands for position.
Oh.
So S of 1. S of 1 is equal to 1.86 times 1. Since we're dealing with decimals, guys, you might need your calculator, which is fine. This will probably be a calculator type question. Are we still okay? Well, our 1 squared is 1. No, you're good, miss. I should have put the square in there. S of 1 plus h. 1.86 times 1 plus h, close it, squared, equals, and I guess anything times, all right, let's just continue. 1.86, 1 times 1 is 1. 1.86 times, 1 times h is 1h, but you're going to have 2 of those, so 2h. And then h times h is h squared. I'm going to distribute that 1.86. So 1.86, and I bet you that double 1.86 is that 3.7 plus, what's 1.86 times 2? 3.72? Yeah. It has to be. And okay, there it is. Now we're going to do our calculus. You guys ready? So I'm going to write, let's see, I'm going to write velocity at 1. Velocity at t equals 1 is equals, and this is probably not the best way to write, but we're rookies, so I'll write it. Limit as h approaches 0 of s of 1 plus h minus s of 1 divided by h. Is everyone okay with how I got that equation? Okay, I just did position final minus position initial, bless you. Equals 1.86 plus 3.72h. Do I have enough room? Yeah. Plus 1.86h squared minus 1.86. I didn't write the word limit. All over h. And write the word limit in front, guys, if you have enough space. Limit h approaches 0. All right, what zeroes out in the numerator? 1.86 is, and now I can factor out h, so I'm going to do it one more time. I'm going to start over here. We're going to have enough space. Limit as h approaches 0. Here's my h factored out. 3.72 plus 1.86h. Close it all over h. what's going to cancel? The h's. What is h approaching? No, h. H is approaching 0. So that 1.86 times 0 is going to be 0. And all I have is 3.72. I didn't get that 1 that Google has, but that's fine. And I need units. Meters per second. Are you shocked that it's 3.72? No, because we got this information from Google that gravity was 3.721 and my initial velocity was 0. So after 1 second, I better be going that number. Isn't this cool, guys?
This makes sense as to why we're doing this. Knowing why we're doing it.
All right, here we go, guys. We got to continue. Yeah, go for it. So these are questions to test yourselves. I will edit the length up for Google, for YouTube purposes, so don't give me downvotes because of the length of time. This video will probably be like an hour and a half long or something, because I got to add yesterday's notes to today's notes, right? All right, so here we go. Take a 1 minute and see if you can do number 1. It's just true or false. What do you guys think? True or false? It's true. Every tangent line has a normal. What's the relationship between a tangent and a normal? They're perpendicular to each other.
So then wouldn't it have to be like -1 over A?
No, x equals a is just a coordinate. At x equals 5, I have a tangent.
We're not asking us about like.
So it's not asking if it's the same.
No, it's not. It's not asking it's the same. It's saying that every tangent has a normal at x equals a. At some x value, if I have a function, you have a tangent. That makes sense, guys? It's always perpendicular.
Because I understood that it always is perpendicular, so then, but isn't it saying that every graph that has a tangent line at x equals something has also a normal line at that same something?
Yeah.
But that doesn't mean that they're on that same line, right?
Is it a perpendicular?
Like, it doesn't matter. Give me a curve, any curve. Let's do one where it has a perfect. Okay. It doesn't matter. Like, even right here where I have a vertical tangent, I'm going to have a horizontal normal.
But that's a different.
Okay, concave up. Every point along this, look, point, point, point. Every point along tangent, tangent, tangent. Normal, normal, normal.
Yes, but the tangent and the normal aren't the same.
The tangent and the normal are the same. They pass through the same coordinate.
But they don't have
That's the definition of a tangent. Okay? Maybe I'm not understanding your question. Tell me again. I'll listen very carefully.
So I'm confused as to what the question is asking, because when I was reading it, I thought that it meant that the tangent and the normal are the same. Like,
No.
The slope of the tangent and the normal are the same.
No. Okay. They're saying. Let's read it. If the graph of a function of the tangent line at x equals a, then the graph also has a normal line at x equals a. This is just a coordinate. So if I tell you that I have a tangent, let's go over here to this one because I drew it. If I tell you that I have a tangent at 2, which happens to be 8, I also have a normal at 2, which will, that normal line, that slope of that green line will be a negative 1/8. That's all it means.
This true false question is not asking about what the line actually looks like. It's just
No.
asking if it counts.
If I have a tangent, do I have a normal? Cool. All right, guys. It says NC, so no calculator. So use your arithmetic skills and see if you can figure out number 2. Take about, I don't think you'll take 2 minutes, so let's take 1 minute. Make an honest attempt, guys. The word average is in there, so you don't need to do the word limit. You can just do plain old good old school algebra. So you're just finding average rate of change. So all you're doing is y2 minus y1 over x2 minus x1. These are x values, x1 and x2. Because it's an interval, they tell you, interval. So I need f of 1, I got 2, and I need f of 3, I got 12. All I'm doing now, 12 minus 2 over 3 minus 1. Let's see if we can do that by just with count calculations. 12 minus 2 is 10, 3 minus 1 is 2, and 10 divided by 2 is? Can we do that? All right, here we go. This one's going to require, well, I guess it's not too bad. Let's see if you guys can do that one. Take 2 minutes on that one, and then we'll pick it up in a little bit. Bless you. Hint, hint, f of 1 and f of 1 plus h. Anytime you read, don't worry, if you're still going, keep going. Anytime you read something that says tangent line, immediately in your brain, something should pop up. You need two things for a tangent line. What and what? Point and slope, always. Point and slope. I kind of already got the point. They wanted at 1. So f of 1 is 2. So my point is 1 comma 2. And I just got that just from plugging in 1 in there. Now I need my slope. So that's where I got to do all this fancy stuff. I don't guess it's fancy. I don't know. If you give this to a 6th grader, will they cry? Okay, well, okay, don't make them cry, guys, because that's just mean. So limit as h approaches 0, and I'm going to write 2 over 1 plus h minus 2 over h. All right, Chavez, now what? So our algebra is what's going to hurt us, not the concepts, because I think you guys got the concept down. Now it's like, what do you do with this? So now you just do algebra, guys. So I'm going to multiply this term on the right by 1 plus h over 1 plus h. Why? Because I have a 1 plus h in the denominator of that numerator, if that makes sense. So here we go. Limit h approaches 0, 2 over 1 plus h minus, and let's distribute 2. Well, I guess for now I'll just write 2 plus 2h over 1 plus h all over h. Now I'm ready. I'm going to put this in parentheses so I can distribute that negative there, guys. So I'm going to write limit as h approaches 0. I'm going to write it like this. 2 minus 2h over 1 plus h. Put that in parentheses. And the h is going to put it right there. Can I do that? Keep, change, flip. Right? Yeah, this is like h over 1. Keep, change, flip. So now, what's up? What's up, Taylor? Side note, AB divided by C, so that C is like that H. I can just bring that C next to that B. A over BC, because that's like C over 1. So keep, change, flip, AB times 1 over C. Okay. All right, I'm glad I got that. We got that out of the way there. What zeros out in the numerator? The 2's. So always cancel those out first, because you cannot cancel the h first. I mean, I guess I can't tell because it's just, it's not like you can record audio of what you're doing when you hand me a paper. But always do that first, and then the only thing you have left is that 2h. Now I can cancel out a what? An h. Now you can cancel it out. Now h is approaching what? 0. H is approaching 0, so this whole shebang is going to equal what? Negative 2. 1 plus 0 is 1. Negative 2 divided by 1. So now I got my slope and I got my point. Here we go. I still got some room down here. I'm going to write y minus 2. That is the coordinate. Not to be confused. Oh, well, it's negative 2 anyways. Then negative 2 is my slope. X minus 1. And I'm just going to solve for y. Y minus 2 equals negative 2x plus 2, and then add 2, So your tangent is y equals negative 2x plus 4. In a little bit, we'll graph it to see. I know it says no calculator, but I want to see the visual. And this one's going to be a pretty one. I'm going to like this one. I'll use Desmos so you guys can see how to use Desmos if you guys want to. Are we okay so far, guys? All right. See if you guys can take 1 minute. You don't have to start from scratch to do question number 4. It's the same equation at the same coordinate. They want the normal. Same coordinate.
Oh.
All you got to do is one thing. So this is asking what type of ramen should she get. I was going to tell her the spicy miso tantan men from the Tenko Ramen. Should she get the Tokyo Shoyu? Should she get the miso corn? The street corn maize man? Those are her only options. Street corn? You sure?
Yes. Where's the
The quarry. I'm going to get her spicy miso tantan. Why not? Huh? What? Yeah, many times. Yeah. All right, let's get back to business, guys. So, what is the relationship between a tangent and a normal? Perpendicular slope. So, what is my new slope? 1/2. So, you're just going to go y minus 2 equals a positive 1/2 x minus 1. That's it. That's all you're doing. And now you're just solving for y, guys. Y minus 2 equals 1/2 x minus 1/2 plus 2 y equals 1/2 x. Let's see. That 2 is the same thing as 4 over 2. So negative 1 plus 4 is 3/2. And this is my normal. Now check it out, guys. Yes, do use your calculator as much as you can, but I'm going to go ahead and I want to see how this looks on Desmos. So I'm going to take out Desmos really quick. And don't worry, I'll get us back to our notes if you need it. So where's Desmos? I thought I had it saved. I don't have it saved. Okay, next time. Desmos. All right, so check it out, guys. Hook me up with, what was the equation? Y equals 2 over x. Come on, graphing calculator. I don't know why it's taking a long time, guys. It never does. Okay, here we go. So, y equals 2 over x. So there it is. Give me my tangent. Y equals negative 2x plus 4. Yeah, look at that. That definitely looks like a tangent. All right, give me my normal.
Y equals 1/2 x
Plus 3/2. Look at that. That definitely looks like a normal. See that right there, guys? Isn't that pretty cool?
Yeah, it's actually really cool.
Yeah, really cool. Make sure that you practice also doing this in your calculator so you can see. And remember, if it doesn't look perfect, square the window. So you got to click zoom and then square. Yes.
Remember when you were going over sinusoids last year?
Uh-huh.
And you figured out how to make them go?
Oh, yeah, the noise.
That was so much fun.
Yeah, that was fun. All right, guys, let me go ahead and stop this recording here.